it's me Sharon. So yesterday I made a video about the elements of the periodic table. I only put alkali metals, that is part 1. So tomorrow I'll do the part 2. For now, I will guys teach you the compounds of sodium, which is referred to as Na. In Greek it refers to as natrium. So now the introduction is that sodium, first we're looking at sodium chloride, NaCl, and NaOH, sodium hydroxide. So for now, we'll look at sodium chloride, which is very short, and sodium hydroxide is very big. So now let's look at sodium chloride or our table salt, NaCl. So if you just think about sodium chloride, you'll just think it of as table salt because it is used for cooking, for every purpose you're using, for electrolysis. It is very, very important, as well as sodium hydroxide. Sodium hydroxide is also prepared by using sodium chloride by also the process of electrolysis, which involves Nelson cell and Castro-Kellner cell. So now we'll be looking at sodium chloride or table salt, which is NaCl. So sodium chloride is obtained by evaporation of seawater because seawater contains 2.17% of mass, which contains sodium chloride. But due to the presence of sodium chloride and magnesium chloride, it has deliquescent nature. Guys, deliquescent means it absorbs the moisture, but it loses its shapes. It loses its crystalline shape and it dissolves in moisture. Hygroscopic and deliquescent. These are two common words used in chemistry, which is a lot of confusing. Hygroscopic, they absorb moisture and they retain their shape, and it is reversible. While as deliquescent, they absorb moisture. They dissolve in moisture. They do not maintain their shape after being absorbed, and they lose their crystalline shape, and it is irreversible, which is a chemical change. So it has deliquescent nature. 28% of sodium chloride solution is known as brine. Brine is used in many chemical industries and chemical factories. So now that we're done with sodium chloride, because this is very, very common, so we do not use like a huge paragraph. But sodium hydroxide or caustic soda have a lot of uses, so we'll be looking at like a lot of them. A lot of uses, reactions, and chemical properties. Chemical properties. So sodium hydroxide or caustic soda, which is commonly referred to as NaOH chemically, it is used in the preparation of soaps, cheaper soaps, if I'm to be honest. So the methods of preparation are as follows. There are like 3 proper methods of preparation. First one is a 10% solution of sodium carbide is treated with a milk of lime. Milk of lime means a certain amount of lime is treated with sodium carbide to calcium hydroxide, which is a bracket. So Na, sodium carbide plus calcium hydroxide, which reacts will give calcium carbide plus 2 molecules of sodium hydroxide. Calcium carbide is deliquescent, not deliquescent but like insurance, and with 2 molecules of 2 mole of sodium hydroxide. So now we'll be looking, this is with the limestone preparation. Now we'll be looking at electrolysis. Electrolytic process involves Nelson cell and Castro-Kellner cell. These 2 cells are huge. They give a lot of importance to these 2 cells, which are the preparation of sodium hydroxide or caustic soda. The amalgam is referred to as alloy of mercury. The amalgam is treated with H2O, which is water commonly, to give sodium hydroxide and hydrogen gas. So 2 molecules of sodium and mercury plus 2 mole of water gives 2 mole of sodium hydroxide and 2 mole of mercury plus H2 gas is evolved. Then now we're looking at the methods of preparation. Now we'll be looking at chemical properties. There are a lot of chemical properties. So it is a hygroscopic, deliquescent, white solid. Hygroscopic, I just said the differences. It absorbs water. Hygroscopic absorbs water, and deliquescent, it loses its, it dissolves in moisture. White solid absorbs CO2 and moisture from the atmosphere. It absorbs the moisture and it dissolves. That is with sodium hydroxide. So its reaction with salts is formation of insoluble hydroxides. So ferric chloride plus 3 mole of sodium hydroxide gives ferric hydroxide 3, which is not possible, and plus 3 sodium chloride. Yes, it has chemical properties, and it can also, even though sodium hydroxide is a salt, it can even react with other salts. So ferric chloride plus 3 sodium hydroxide gives ferric hydroxide 3 moles down plus 3 mole of sodium chloride. So guys, I'll just give you a second or maybe a minute to look at this. So now I'm back. Now we'll look at formation of unstable hydroxides. This is insoluble, which means they do not dissolve in a liquid. So now we'll be looking at formation of unstable hydroxide. Unstable means they will not be stable and could react vigorously. So these are the unstable hydroxides. So 2Ag. Ag means silver and Au means gold. As Au means aurium, Ag means magnesium. So 2 molecules of AgNO3 plus 2 moles of sodium hydroxide gives out 2 mole of NaNO3 plus 2 mole of silver hydroxide. So 2 mole of silver hydroxide reacts with silver dioxide, which is brown in color, or dioxide, but it also gives us water. And the silver oxide is brown in color. So now we'll be looking at reaction with metals. So less electropositive metals such as zinc, as Zn is zinc, or Zn, Z is it simply, Zn is it zinc and Z, so Al aluminium, and Sn. What do you mean by Sn? Sn means antimony. Yes, antimony, or no. Sb means, so Sn means tin. So tin, etc. give hydrogen gas with sodium hydroxide. So zinc reacts with sodium hydroxide gives Na2ZnO2 plus H2 because it gives out hydrogen gas. Whenever it reacts with metal, sodium hydroxide, it always gives hydrogen gas. It is for sure. So now we'll be looking at, reaction with sand. Sand is commonly referred to as sodium silicate. So now we'll be looking at 2 mole of sodium hydroxide plus silicon oxide. So now if it reacts with this, these 2Na will react to this because hydroxide is a different element. So 2Na2 because there are 2 molecules. So now we'll be looking at this 2, and hydroxide is remain same. So these 2 will react to this, and now 2 will go to here, as there is also another compound over here. So 2 will go to here, and the 3, how it comes 3 is because the 2 is going through here, because this space is drawn by 2 plus 1, so it becomes 3 molecules. So now we'll do a sodium silicate plus H2O. This is a reaction with sand. It is actually quite complicated, and I'll just teach all the chemical reactions. So Na sodium carbide. So Ca, Na is 11 and C is 20. So which has more type, which is more, the atomic number for this. So calcium. So calcium will react with CO3. So CaCO3 will down go because this is down, it's down, and 2 OH2 react to this 2 and 2, this 2 will go over here, 2 molecules, so 2 NaOH. So the first reaction, and this reaction is actually quite complicated. So 2 NaOH is released. So how 2 NaOH is released is the 2 molecules of H2 will react to this, will give out, I told yesterday, so it will give out Na oxide, sodium oxide, 2. So that will react with this hydrogen gas, so it will give out 2 NaOH. So give us, and mercury will react to that mercury will react to the hydrogen, and that will give us up to this, and this thing, which is sodium hydroxide, will repeat go on to here, and this completes a complete cycle, and this is known as the amalgam is treated with hydrogen H2O to give NaOH and H plus gas. I know most of you understand it, right? So now I'm looking at that. Now we'll look at this. So ferric chloride plus 3 NaOH gives this Na, and Na will react to form NaCl, 3 molecules, and also 3, so 3, and there's only 1 3. So now this Fe, which is ferrum, and this O is remaining. So these two will react as the 3 is over here because this is a complete compound. This 3 will also go to ferrum, and this will go because mostly iron doesn't form in hydroxide, so it remains with a bracket with a 3 on top, with a cherry on top. Now we're looking at formation of unstable hydroxides. So 2 AgNO3. So now silver will react with hydroxide because silver hydroxide is a thing. Because silver also found as Fi. So now, pardon me. So now 2 Na will react to NO3 to form 2 NaOH plus 2 AgOH. So this AgOH becomes unstable. Yes. So 2 AgOH will become brown after contact with plant, also gives out water. So it's a brown, the formation of ferric. So now we're looking at reaction with metals. So zinc, if it forms, it will form the Na, the 2 will come over here because this is a compound solution. So how it is forming is, so if it comes there, so Na2 and the zinc will come over here, form oxide because this is O2. So SnO2, and the remaining H will be as hydrogen gas. Dissolve this thing, which is reaction with metals is created, and reaction with sand I just told you. And the last point of chemical properties is that a mixture of sodium hydroxide and quicklime, just calcium oxide, is known as soda lime. So now we have come to chemical properties, guys. Just give you a look to go through. Yes, so I'm back. Now we'll look at physical properties. So now that we have known is sodium hydroxide is a hygroscopic deliquescent white solid and also absorbs CO2 and moisture from the atmosphere. That is a chemical property. Now we'll look at physical property. Sodium hydroxide, or commonly referred to as NaOH, is a white translucent solid. It is readily soluble in water. Crystals of NaOH are deliquescent. There are three, three types of known forms. It dissolves in water, dissolves in moisture. There's moisture. Next one is doesn't retain its shape. The last one is irreversible. This is known as a property of deliquescent. Its property is known as deliquescent and this both are the same thing, but the property and the reaction is very similar. So now guys, we'll do a quick recap. Now we're looking at compounds of sodium Na, part 1, sodium chloride and sodium hydroxide. So now we're looking at sodium chloride or table salt, NaCl. So NaCl is obtained by evaporation of seawater, but due to the presence of calcium chloride and magnesium chloride, it has deliquescent nature. 20% of NaCl solution is known as brine. Second, sodium hydroxide or caustic soda, NaOH. Methods of preparation. A 10% solution of Na2CO3 is treated with milk of lime. Na2CO3 plus Ca bracket OH bracket close 2 gives CaCO3 down plus 2 NaOH. Electrolytic process involves Nelson cell and Castro-Kellner cell. The second one is electrolysis. Third one is the amalgam associated with H2O to give NaOH and H plus gas. 2 Na minus or hyphen Hg plus 2 H2 gives 2 NaOH plus 2 Hg plus H2. Chemical properties. 1. It is a hygroscopic deliquescent white solid, absorbs CO2 and moisture from the atmosphere. Reaction with salts. Formation of insoluble hydroxides. FeCO3 plus 3 NaOH gives Fe bracket OH bracket close bracket 3 down plus 3 NaCl. Formation of unstable hydroxides. 2 AgNO3 plus 2 NaOH gives 2 NaNO3 plus 2 AgOH, which is unstable. So the unstable, which is 2 AgOH, gives Ag2 oxide or O, which is brown due to the compound of red, plus H2O. Reaction with metals. Less electropositive metals such as Zn, zinc, Al, aluminium, and Sn, tin, etc. give H2 gas with NaOH, which is sodium hydroxide. So Zn plus 2 NaOH gives Na2ZnO2 plus H2. Reaction with sand. 2 NaOH plus SiO2 plus 1 gives Na2SiO3, which is sodium silicate glass, and H2O. Fifth one, a mixture of NaOH and quicklime, which is calcium oxide, is known as solid lime. The physical properties of sodium hydroxide are as follows. Sodium hydroxide is a white translucent solid. It is readily soluble in water. Crystals of NaOH are deliquescent, or properties of deliquescence are dissolves in moisture, doesn't retain its shape, and it is irreversible. The process by which deliquescence is referred to as deliquescence. So guys, now I have done the video. Now the video is done. I want you guys to subscribe, like the videos, and turn on the bell for more notifications for you to pop up. So bye guys, see you tomorrow. I'll also post a new video about chemistry or any other subject I have in mind of. So guys, see you tomorrow. Bye. Just let me know if you understood the concept of compounds in sodium Na, or I'll do a part 2 of tomorrow with sodium bicarbonate or sodium oxide, washing soda or baking soda. Okay, I'll do that. So now, like I see tomorrow.